Now we move on to Alice Kosgei from Machakos University College, Kenya, talking about integration of drought-tolerant traits into adapted Kenyan chickpea varieties using marker-assisted backcrossing.
Can I move with the which one is it? Okay, good morning. I'm Alice, and I want to thank Rajiv and the organizing committee for this opportunity. I'm presenting on integration of drought-tolerant root traits into adapted Kenyan chickpea varieties using MABC. As an introduction, we say the land in Kenya, 80% of it is semi-arid, and the current state is that we have dry areas having 100% crop failure. Then again, we also have 30% of the population which live in these areas who are currently food insecure, that is, we have a widespread of famine. Then we have also rainfall and high temperatures, or high rainfall which is coupled with high temperatures, which has led to this major biotic stress, that is drought. And chickpea is also affected by terminal drought, which has been shown to have 58 to 95% yield loss, according to Lepot et al. Therefore, there is need for drought-tolerant genotypes, which are actually chickpea-line. As a methodology, there's first the selection of parents, that is parents and also the markers, where we had a total of 33 genotypes which were used from different countries. The screening of the screening of markers, mainly the SSR markers and also specific markers, which were actually developed by IFRISAT India in courtesy of Rajiv and his team. And the SSR markers were mainly meant for the foreground selection, which is to track the QTL region from the genotype ICC, which was developed, which is also regarded as the hotspot region for the QTL region. We saw it yesterday and also this morning in our by our first presenter. The slip markers were mainly meant for background selection. And from the plants that were developed, selection was there, plants which had more than 85% of the recurrent parent recovery. This is the scheme that was used to develop the MABC lines. And we also had early generation evaluation, which was done, although I will not present on this so much because it was just done on one site. It was just to see whether there's any something that we can get from it. But we had the root evaluation, which was done at Backross 2 F3. This is a procedure for scanning steps and also the site where the genotypes were evaluated, that is under rain shelter at Egerton University using pot experiment. Then we had the screening process whereby the spreading of the roots was done on trays, then the scanning process, and then we had the scanned image, and from which it was analyzed using WinRISO software. The results that were obtained from the SNP and also the SSR markers, we had polymorphic markers which range from 1 to 5 and also 12 to 14. And this one was actually supporting the issue with which had been found that there was actually low polymorphism in chickpea and due to low genetic base or diversity. And then again, most of the root traits which we will see and also shoot dry weight were mostly significant for these two varieties, the two of them which were used. One of the varieties is ICCV 92944 obtained from ICRISAT India, which is released currently in Kenya as Chania Desi 1, Desi 2. And then we had ICC 00108, which is currently released as LDT 068. From this table, these were the traits that were done, that is rooting depth. We also have total root length, length, density, root dry weight, and also all this. And from the results that were obtained, we can see here, I've only presented the top 5 based on the total root length. And we can see that there was an improvement in terms of the total root length and also root dry weight. And we also had this root shoot ratio in terms of the first cross, that is LDT 068 by ICC 4958. And again, in the second cross which was done, we also had an improvement in terms of total root length and also in terms of root length density, and again in terms of root shoot ratio. This one shows the root enhancement from the roots that were extracted. You can see here, these are the generations that were developed, the backrows generations, and it shows that there was an improvement in terms of roots compared to ICC 4958. And here we have our parent. The same thing also applies to the other set, which also had improvements compared to our recurrent parent, which is ICC 00108. Again, the same thing here. This is ICC 4958, which is also shown to have the root QTL, which is good in terms of root characteristics. Then here we have our backrows 12-3 families, which were also shown to have more improvement in terms of the root traits compared to our parent, or one of the parents, which is ICCV 92944. So this one, it was a improvement in terms of what we observed. And in terms of conclusion, we can say from the SSR and the SNP markers that were used, there was actually low polymorphism in chickpea. And we are having a lot of research by several researchers to improve this in terms of using maybe the wild relatives to come up with a high polymorphism in terms of the chickpea lines. Then again, from the several families that were obtained, we had a total of 20 which had enhanced root traits compared to their parents. And actually, these are being advanced at Machakos Agricultural Training Center. And then later on, we will have yield evaluation. Although initially we had an early evaluation in terms of the yield, which is shown here that early generation yield evaluation showed that there is prospect in terms of enhanced yield. And then again, there was also positive correlations which were observed among the different root traits. And therefore, we can say that there was a successful integration of drought-tolerant root traits into the two Kenyan chickpea lines, that is Chania Desi 2 and also EDT 068. I wish to acknowledge the funding organization, that is AGRA, ICRISAT India, and also Nairobi, then GCP and LGC Genomics, that is in UK, the various institutions, that is my institution, WAKI, then University of Ghana, Egerton University, Machakos University, then the ministry, and also ICRISAT staff, that is Genomic Labs India, a biotechnology lab in Kenya, friends and colleagues. Thank you.